In this video, we're going to continue to look at zeros and factors. Now, I want to start off with a question to think about. Is 5 a factor of 50? And the answer is yes. But what I want you to think about is, how do you know that? I mean, what did you do to figure out if 5 is a factor of 50? There are several different ways that you can go about kind of explaining your answer, but basically it means that 5 goes into 50 evenly. And in other words, when you divide, the remainder is 0. So we're going to continue to use the remainder theorem to figure out if a binomial is a factor of a given function. In this example, I'm asked if x plus 2 is a factor of a given function. Now this is equivalent to asking, is negative 2 a 0 of the given function? So one way to figure out the answer is to evaluate the function at negative 2, and I get 0, so my answer is yes. The factor theorem says that I can use synthetic division, and if my remainder is 0, then x plus 2 is going to be a factor. And using synthetic division, I bring down this first number, multiply, add, multiply, add, multiply, add. So f of negative 2 does equal 0, so this is a factor. Another way that I can figure out if x plus 2 is a factor is I can put my function into the calculator and graph it and look at the table or look at the graph. In the table, I can see that I've got the point negative 2, 0, so negative 2 is a 0, so that means x plus 2 is a factor. And according to my graph, I've got an x-intercept at negative 2. So again, that indicates that x plus 2 is a factor. In this example, I'm asked if x minus 3 is a factor. That's equivalent to asking if 3 is a 0. So again, I've got several different ways to do this problem. I can evaluate the function at 3. When I do, I get 2. So my answer is no. I can do synthetic division with 3, and I have 2 for my remainder, so f of 3 is equal to 2. So when I use synthetic division, I get a remainder of 2, so f of 3 equals 2. And because I have a remainder, that means that x minus 3 does not divide evenly, so it's not a factor. I actually want to start by looking at this graph here on the top. It looks almost like I've got a 0 and 3, but if you zoom in real close, you will see that I don't. This graph doesn't quite touch at 3, and I can verify this by going and looking at the table. My graph does not have a 0 at 3. F of 3 is equal to 2.